In the last part of the question 3, we are supposed to find an expression for this gradient operator or gradient functions applied on f, which can be written as gradient dot product on f. But we already obtained an expression for this one. That was grr plus 1 over r gr plus 1 over r square g theta. But I can also write the expression, basically this is a Laplacian operator, partial square over partial x square plus partial square over partial y square. But instead of using in the Cartesian, we can write in the polar form. So this will be this is the operator being applied over here. So this will be basically partial square over partial r square plus 1 over r partial over partial r plus 1 over r square partial square over partial theta square. So that is being applied on this grr plus 1 r gr plus 1 over r square g theta. So let's apply every expression on all of the expressions. So we start with the very first one, partial square over partial r square applied on grr plus, this partial square will be applied to whole of the expressions, plus partial square over partial r square applied on 1 over r gr plus this partial square over partial r square applied on 1 over r square g theta theta. Similarly, the second will be applied over here, so it will be 1 over r partial over partial r applied on this grr plus 1 over r gr plus 1 over r square g theta. I just distributed it combinedly. The last one is 1 over r square partial square over partial theta square applied on grr plus from here we have 1 over r square that will be outside, so 1 over r square into partial square over partial theta square applied on 1 over r gr and plus last term will be 1 over r square partial square over partial theta square 1 over r square g theta theta. Now we try to simplify every term. So here this is the derivative of g with respect to r already, and taking derivative double derivative again with respect to r. So this will be just grr 4 times, and here we have to apply the double derivative with respect to r on this product. That so it means product rule will be applied, but I'm going to apply it in 2 steps. So firstly I will write one derivative outside, and we apply the product rule 1 times on this one. So this will be negative 1 over r square gr plus 1 over r, and because we have applied derivative with respect to r once, that will be grr. And on the last term we can again notice this is also double derivative with respect to r, and both of the terms depending upon r. So again we will be writing that partial r outside 1 times, and 1 times we will apply the derivative over there. So when I apply the product rule over there, it will become negative 2 over r3 g theta theta plus 1 over r square gr theta theta. Let's go to the next line. Here, because this was a single derivative, so I just have written a combining. So first term 1 over r will come outside, and this derivative will be applied on grr. There is already grr, so it will become g, third derivative of g with respect to r. Then for this term it means we have to apply the product rule, so it will be negative 1 over r square gr plus 1 over r grr. last one, again we have to apply the product rule with respect to r. So derivative of this r 1 over r square will be negative 2 over r to power 3 g theta theta plus 1 over r square, and then it will be g r theta theta. And let's go to the last line. So here we have 1 over r square, and derivative of g r r is being taken with respect to theta twice, so that will be just g r r theta theta. And here, because we are taking the second derivative with respect to theta, and keeping in mind this 1 over r is independent with respect to theta, so this will just come outside. So outside it will become 1 over r cube, and this second derivative with respect to theta when applied on gr, so it will be just gr theta theta. Similarly, in the last one, again this r 1 over r square is independent of theta, so it will come outside. It will become 1 over r to power 4 and g theta 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 4 times. Now we again go back to the very first line, and we again apply the product rule wherever it is required. The first term is g r r r plus, okay, now I'm going to apply the product rule or any rule which is required over here. So firstly, product rule will be applied over here, and the product rule will be applied on this term as well. So let's apply separately. So if I apply the product rule on this one, so the derivative of that negative 1 over r square will become it will become 2 over r3 and gr, then it will be negative 1 over r square remains as it is. The derivative of gr will be grr, and then the derivative of this one, when we apply the product rule on this one, it will become negative 1 over r square grr plus 1 over r g third time r. After that, again we apply the rule over here, and the product rule is to be applied on both terms, because this terms in g theta theta is also a function of r, and this is also a function of r. So let's apply the product rule over here as well. Let's apply on the first term. For the first term, I have to take derivative of this negative 2 over r3, so that will become positive 6 over r to power 4. G theta remains, g theta theta will be as it is, and then negative 2 over r cube as it is. The derivative of this will be with respect to r. Now we apply the product rule on this term. It will be negative 2 over r cube gr theta theta plus 1 over r square. It will be grr theta theta. Now I go over here and just multiply with 1 over r wherever it is needed. So it will become 1 over r g r r r negative 1 over r cube gr plus 1 over r square g r r negative 2 over r to power 4. It will be g theta theta plus 1 over r cube g r double theta. And from this last step, we have already simplified everything. That's 1 over r square g r r theta theta plus 1 over r cube g r theta theta plus 1 over r to power 4 g theta theta theta. Now we combine these terms, but for combining I start with the lower index of g with respect to r. So let's look at the terms which involve gr. So here is one term, 2 over r3 gr, and then we have another gr, it's over here. So if I combine them, they will give me 2 minus 1, that will be 1, so it will be 1 over r to power 3 gr. After that, we look for the terms of grr. So here is a term of GRR, and then let's look if there is another term of GRR is over here, but they are same and with opposite signs, they are cancelled. And there is one more term with GRR, this is that one, so that is negative 1 over r square GRR. Now we look for the terms which will contain 3 r's, GRRR. So first of all, here is a term, then this is also that term GRR. Let's look if there is any other term. No, there is no other term. So these terms 1 over r GRR and 1 over r GRR, so they will combine and they will make 1 over r GRR. Now let's look at term if there are terms with GR with 4 times, and that seems only a single term, the first one, this one. So that term will be GRRRR. Okay, so we have arranged in a way that this is GR, then G double R, then G triple R, then G tetra R. Now I will start with theta, but with a maximum of theta. So maximum of theta, if we look, it's over here, 1 over r to power 4 G theta theta theta. Now we will be looking at terms in which there are 3 thetas if there is any term. But I don't find any term with the 3 thetas. But now let's look at term with 2 double thetas, with only thetas, no r. So let's look if there is any term with double theta. It is over here, this one, and any other with double thetas, this is over here. So if we combine these two terms, I mean this term 6 over r to power 4 G double theta, and here it is negative 2 over r to power 4 G double theta. So it will become 4 over r to power 4 G double theta. After that we look if there is any term of single theta, but I cannot see any term with single theta. There is no such term with single theta. Okay, now we come terms with combination of theta and r, but firstly I will be looking with more theta than less r. So let's look if there are 3 thetas and single r. There are no 3 thetas and single r, but let's look at double theta and double r. So no, double theta and single r first. I mean the less r I want to combine in a nicer pattern. So here is the term, this is the term over here, double theta and single r, and again double theta and a single r, and double theta and single r. So these are the 3 terms, and again here is double theta and single r. If I combine these 4 terms, so this is minus 2 minus 2 minus 4 and plus 1 and plus 1 from here, so it will become negative 2 over r to power 3 G double theta and single r. Instead of writing as r theta theta, we can of course switch them, so this can be written as G theta theta r, because I want to write in a nicer pattern. It's 4 thetas, then 2 thetas, then 2 thetas and r, and lastly I think we are only left with the terms which have double r and double theta. So let's try to find those terms. Here is a term 1 over r square G double r double theta, 1 over r square G double r double theta, and that's it. So that will be the 2 over r square G double r double theta. That's it. This was the required expression. We were looking for the square of the dot product of gradient.